What up, Gago students? Here's the new video. Gotta keep it fresh. Related rates, calculus word problems, so necessary to do it by yourself. I'm gonna give you the answers, but if you're just copying down, you're wasting your time. Okay, you gotta try, just like we did in class. And you gotta eventually figure it out, start getting it. You'll be very much rewarded. These are tricky problems. It starts with being able to take derivatives of equations with respect to t. Being able to do it comfortably, not being freaked out by it. Being okay with getting dp dt, and knowing that it means like the change in my perimeter at a moment in time. dl dt, change in my length. dw dt, change in the width. I'm going to change this to an area of a square. Square's area is a length squared. Perimeter of a square would be 4 times my length. But taking the derivative of this, dA dt equals 2L dL dt. Some things to know. Oh, I'm tired. Both sides of the equation count. Make sure you have the left side and the right side, or else don't even bother, you're going to make mistakes. People will write pi r squared. They'll take the derivative. They'll get 2 pi r dr dt, but they won't know what to do with it. So, hey, heads up, listen to me. Listen to me. Have A equals, have the derivative, and get dA dt equals. All right. This one, perimeter of a circle, this is circumference. You'll see this one in the class / on your homework and test. C dc dt equals 2 pi. 2 pi is just a constant, so don't worry about it. R's derivative is dr dt. This was a good one. Relationship between the radius and the diameter. Radius is half the diameter, or double the radius is the diameter. It doesn't matter what you want to do. Just be able to understand this, and you get 2 dr dt equals dd dt. Heads up. Heads up. Sometimes a product will show up and product rules still apply, and for good reasons, for legitimate reasons, people forget about the product rule because it's like, it's not X's and Y's. But that's it. Pythagorean theorem, we're going to use a lot in next class. A squared plus B squared equals C squared. We're going to say horizontal distance squared plus vertical distance squared equals diagonal distance squared. And when you take the derivative of this, you'll see, and this is something that we like to do all the time, you cross out the 2's. Cancel all the 2's because every single term is a 2. Okay. Spheres we'll see. R's 3 is going to come down. You have 4/3 pi times 3r squared dr dt. The 3 and the third will cancel, giving us 4 pi r squared dr dt. Okay, that's dv dt. Cylinder, cones will show up. I don't want to give you this. R is 4. Let's pretend that wasn't there. If you take the derivative of a cylinder as you see it, it's a product. You need to use the product rule. This is especially important if you have a cylinder that every aspect of the cylinder is changing. The radius is changing and the height is changing. Maybe it's not realistic, but it's done. Derivative of the first times the second plus the derivative of the second times the first. Now, Let's say you have a cylinder with water in the cylinder. And the cylinder's not changing, but the water in the cylinder is. Okay, the water is like, we're like pouring water into the cylinder. The height is changing. Well, if we're talking about a cylindrical tank, the water in the cylinder has the same radius the entire time because the tank's not really growing. It's the water in the tank that's changing. If this was the case, and let's say your radius was 4 and your radius was 4 all the time, then you can have a new formula for the volume of your tank. This is something fixed that can be used to your advantage. And this is more important on the next class. That if you have something always true, it can be plugged in earlier on. If it's not always true, you don't plug it in earlier on. You wait till after you take your derivative to find how quickly things are changing at moments in time, at the moment when this was 4. If your radius of something is always 4, you can plug it in early. Big mistake with these problems is people plugging in things too early. Okay? Some things to note. Let units help you. For example, if you have units cubed, volumes. If you have squared units, areas. If you have units to the first power, lengths. If you just have, say, meters, that's just a length, a radius, a side length. But if you're talking about how things are changing, you would see meters per, say, second. This is a length. This is a rate of change or a derivative. So meters per second, feet per minute, yards per hour, whatever. If it's blank per blank, it's like a velocity. It's a rate of change. We'll talk more about velocities next class. But if you see this cubic feet per second, that's a change. If you see cubic feet, that's a change in a volume. So you put those two together to get dV dt is 10. Don't worry about the units after like we know them. But like let the units help you versus being afraid of units. Our answer is we don't really worry about units. Surface of a square is increasing by 4 squared meters per second. It's probably talking about the surface area because it's squared meters per second. So this is like an area and it's changing meters squared per second. Let's call that a cube. Surface area of a cube is increased by 4 meters squared. This is an area because of the meter squared. Unless I screwed up with the problem. That's interesting. Boom. Squared. Areas. Rate of change. If a derivative is positive, the original thing must be increasing. If the height is decreasing, if something is decreasing, the derivative must be negative. Important. The sum of x and y are constant. Write an expression that gives a relationship between how quickly x and y must be changed. I don't know why I put this problem in here, because I don't think it shows up at all. But directly related, opposite of each other. Good problem. This problem. Because it's very standard, very simple, really range problem. They've given you an equation. It's got different variables, x's and y's, which we're used to, but now a w. It's got a bunch of statements that you have to translate. X is decreasing at a rate of 2 units per minute. dx dt is 2 units per minute. That's your indication that it's a rate of change. Y is increasing at a rate of change, a derivative. dy dt equals 3. At what rate is W changing? How quickly is W changing? Rate of change, derivatives. Derivatives are rates of change, dW dt. I don't know what that is. At the moment when x is 4 and y is 5. You're going to take the derivative of your equation. This is where a lot of people don't know what to do, but like you need a derivative. Don't forget. I get dw dt equals product rule, derivative of the first. Don't forget the dx dt times the second. I know with x's we're used to not having it, but like you're going to have it. Derivative of x's or dx dt because we're taking derivatives with respect to t times y plus the derivative of y times x squared. X is 4. Dx dt is 3. Y is 5. dy dt is 3. X is 4. dw dt is all that. Whatever it is. 48. Okay, what am I doing here? 120. 10 times 12. 168. Units per minute. Do I care? No, I don't really care about the units. Okay. Another easy one. Giving you the formula. I don't know why I gave you this question. This question is volume of water determined by its height. Here's the volume. They gave you the equation. That's nice. Find the rate of change of the volume of the water. Find the rate of change of the volume of the water. Find the derivative of the volume. Rate of change. Rates of change are slopes, are derivatives, okay? Calculus is the math of change. Derivatives are how quickly things are changing. Increasing, decreasing. We've talked about this. Height is changing 1 foot per second. Height is 2. Okay. I'm probably going to distribute this just because I don't want to use a product rule when I don't have to. I'm going to take the derivative of this. Don't forget you need a derivative. If you're just copying this down, why are you wasting your time and my time? Honestly, you should just fast forward to the answer. See if you can get the answer, you know? And then if you can't get the answer, go back and see how I did the problem. Can we do that? Is that a good idea? I think it is. Look at the answer, go back and do the problem. I like this. There's the answer. Try to get that. Determine how quickly the base area is changing. Given the surface area. I'm giving SA, so it's like DSA is 10 when B is 5. So I think I want you to like take the derivative of this and freak out a little bit. Don't freak out. The derivative of the surface area is dSA over dt. Well, let's think about this. The derivative of e to the x is e to the x, right? You've said the derivative of e to the y is e to the y dy dx. The derivative of e to the b would be e to the b times db dt. The base is 5. dB dt, I'm trying to find dSA dt is 10. I mean, like, the answer is 10 over e to the 5th. See if you can get that. Go back. See what I did. The balloon's a sphere. It should say a spherical, but it doesn't. Cubic feet per second. How fast is the radius changing? Cubic feet per second. Volume. Change in a volume. Feet per second. Volume. 3r squared. The 3 times the 4/3. Boom, 4. Make sure you solve for the correct thing. 1 over 10 pi. How quickly is the surface area changing? Can you take a derivative correctly? Are you remembering the d blank dt? If you're not trying this, you're not helping yourself out. You know who you are, too. You copiers of homework. I don't know what I'm doing, but I always have my homework done. R was 5. dr dt is 1 over 10 pi. I just found that. That's an example of like doing two things at once. The pi's will cancel. 5 turns that into a 2. You get 4. All right. Yep. 40 pi over 10 pi. All right. You will be given the equations, all the equations you need. I'm tired of like fighting with people in equations. So like you will be given circles, spheres. I'll give you everything. Okay. I shouldn't give you like rectangles and squares, but whatever. I don't care. Surface area of a sphere is 4 pi r squared. You'll be given that. Volume of a sphere is 4/3 pi r cubed. You'll be given that. Surface area is growing by 20 squared feet per second. Feet per second, rate of change, derivative. Okay? How quickly things are changing. 20 feet per second, y's per x. How fast is the volume of the sphere growing when the radius is 2 feet? It's not that the radius, dr dt, is 2. That's important. dr dt is not 2. R is 2. It's not feet per second. It's just feet. We've taken these derivatives before. I'll do it again. The 2 comes down 2r dr dt. The 2 times the 4 pi is 8 pi r dr dt. 3r squared. The 3 times the 4/3 makes it 4. Use what you know. Divide by 16 pi. That pi is in the denominator. If people are going to make mistakes, it's because they are not comfortable having pi's in denominators. That's dr dt. That can be replaced here so that you can find dv dt. We did something just like this. In the notes. Sphere is expanding in such a way that the area of a circular cross-section through the sphere center is increasing at 4 centimeters squared per second. How quickly is the sphere's volume changing when its radius is 3? This one's tricky. A circular cross-section through the sphere's center is increasing at 4 centimeters squared per second. That's an area. That's some dA dt is 4. Talking about a sphere, you're asked how the sphere's volume is changing. The radius is 3. You know the volume of a sphere. You know the derivative of that. But how the hell do you use this dA dt? Well, it's a circular cross-section. So it's like when you slice into the sphere, you see a circle. The area of that circle. Pi r squared. Probably won't give you that. Probably will say, like, here are a bunch of formulas. You guys choose the right ones to use, you know? And you'd have to know to use this one. You know what I mean? dA dt is 4. R is 3. Going to find dr dt that way. Divide by 2. 2 over 3 pi. The world is coughing. I've had this shallow cough for this last week, and it's like very annoying. I'm trying to like sleep. I've been very healthy, trying to sleep lots, and it's like I don't know if I'm getting better. I feel better today. I went down a little bit yesterday. I feel better today, but I'm still coughing. Hopefully I'm getting better. All right. You still need the derivative of v because you're trying to find dv dt. I know what dr dt is. I know what r is. So I'm finding dv dt with 4 times pi times 9 times 2 over 3 pi. The pi's will cancel. Nine divided by 3 is 3. 3 times 4 is 12. Times 2 is 24. That's the answer. Oh. Area of a square is a length squared. Area is increasing by 2 feet per second. How fast are the side lengths changing when the length is 4? Look at the answer before looking at it. Don't look at this. Don't look at this. Start over. What are you doing? Rewind, pause. Don't copy what I put down. That is not helping you. Try to get the answer, then go back. We did this in class. This is the fun one. At some point, the area of the circle is growing at twice the rate of the circumference. So many different ways. So many different ways to do this problem. dA dt is 2 dc dt. I can go ahead and plug 2 dc dt in for dA dt. I can divide by 2, and now I have an expression for dc dt. dc dt equals pi r dr dt. The dr dt's cancel. Divide by dr dt. Divide by pi r's 2. Cool. The circumference of the circle is growing at that. The square expands to maintain its tangency. Find the rate at which the perimeter of the square is increasing. Well, the perimeter of a square is 4 of my lengths. These are L's. So dp dt equals 4 dl dt. What's L? What's dl dt? Well, this is my radius, right? But 2 of my radiuses, which equals my diameter, is equal to my length, which means a radius is my length divided by 2. So if I have my circumference, the change in my circumference is 2. It's actually this. 2r equals L. Like you get dc dt equals 2 pi dr dt. Okay, what's dr dt? Because then if you know dc dt is 6, what the hell is dr dt? Because if you have dr dt, you'll find dl dt. And if you have dl dt, you'll find dp dt. This is a good question. dr dt is 6 over 2 pi, or 3 over pi. Twice my radius is my length. This is very much like the diameter problem that we are giving in class, which means twice the radius of my diameter is equal to twice the derivative of my radius is equal to the derivative of my length. If dr dt is 3 over pi, then 2 times 3 over pi is dl dt. And that goes there, and dp dt equals 4 times 6 over pi. And that's it. Cool. Leading us into next class majorly. If there are things that are fixed, you can use it to your advantage. For example, a rectangle has an area length times width, right? Quickly, is the area of the rectangle changing when its width is 5? And the width is growing at 2 inches per second. How do I know that that's not a dA dt? Because it's inches to the first per second. It's very important. Okay. Now, you know the rectangle has a length of 4. There's 2 things to do here, guys. If the length is 4, now you have to, it's a little tricky to read into this. It should probably say, hey guys, the length is 4 and the width is changing. The length is always 4, it's the width that's changing. It doesn't say that, so I can see how you get confused here. So probably if I were to write this question for a quiz, just to make sure it's clear, the length is always 4, whose width is growing in size. Okay? Why is that important? It's like, well, if you took the derivative of this, you need to use the product rule. The problem with that is you got L, okay, that goes there. You got dW dt, that goes there. You got W, okay, that goes there. But what the hell is dL dt? Well, L is always 4. Its length is always constant. Its derivative is 0. That is one thing you could do. Understanding that if things are constant, its derivatives are 0. You can then realize that this means nothing, and you just have 2 times 4, which is 8. You don't even need the width. You just need the change of the width. Or you know L is always 4. The area of any rectangle is L times W. The area of this specific rectangle is always 4W. Watch how this works. dA dt equals 4 dW dt. I get that answer 8 without having to know that dL dt is 0. We'll see that next class. There are situations where you can either just take the derivative and know that d blank dt is 0 because it's fixed, or plug it in earlier. It'll help you be able to get the correct answer a little bit easier. For example, I'll give you the formula for a cylinder, pi r squared h. The radius of this tank is 2. Now, if you have a cylindrical tank, the water in the tank, if the tank's radius is 2, the tank is not changing in size. It's the water inside the tank that's moving. So you could either take the derivative of this and understand that if R is 2, dRdt is 0 because the radius of the water in the tank is not changing. It's just the height of the water is. Or the radius of the tank is always 2. The radius of the water is always 2. It's a fixed value. You can change this to 4 pi h. Now, again, if you wanted to, you could take the derivative of this. You just have to use the product rule. It's gross, and you need to know that dRdt is 0. But instead, use information that's fixed to your advantage. This is the volume of this tank, this cylinder. You get dV dt equals 4 pi dH dt. Look at that. Losing water, dV dt is -4 because volume is decreasing. -4 equals 4 times pi times dH dt. How is the height of the water changing? -1 over pi feet per whatever. All right. Hope you're picking up what I'm putting down. If not, whatever. They only get harder. Peace.